How's it going, everyone? Now, first of all, we all love proof of math. As we just heard from Ellie, it's the most secure way for us to transact on the internet. And, an oft unappreciated but still very large chain is Dogecoin. And today we're going to be talking about how we built a trustless zkRollup on Dogecoin. So, just a really quick intro, I'm Carter. I'm the CEO of QeD. We're a zk layer 2 targeting both Bitcoin and Dogecoin. I've built a lot of stuff. I used to be a proof of stake guy. I was converted to the light side of proof of work. And we've been building QeD for about a year and a half. So before we really dive in here, it's important for us to think okay, what exactly is a zkRollup on Dogecoin? Well, fundamentally, you can see a bunch of details up here. But the main thing that we want to see in a zkRollup is that the only way I can steal your assets on the zkRollup L2 is if I break Dogecoin itself, right? So if we want to say that a zkRollup has the security of Bitcoin or Dogecoin, what is the metric of that? Well, it's if you can break that L2 in some way without having to break Bitcoin or Dogecoin itself, then it's probably not inheriting the security. So we want to make sure on any zk L2 that we can deposit in this case, Doge, from layer 1 to layer 2 fully trustlessly. And that I know when I do that deposit, I'm going to be able to claim it on the L2, and no one else is going to be able to. In addition, we want to be able to transfer tokens back and forth on the layer 2. So QeD Rollup, as we've implemented it yet, thus far, it doesn't have smart contracts because it's more like a technical POC. QeD, though, is coming soon, so that will have smart contracts. And we really want to be able to do 100,000 or 1 million transactions and have the on-chain footprint for Dogecoin be constant size or be very small, meaning that no matter how many transactions we do on the layer 2, that the layer or that are secured by the layer 1, we don't want to flood that layer 1 with transactions. And in the case of Dogecoin, the block size is only 1 megabyte, which is even smaller than Bitcoin. And then finally, of course, we're transacting on the layer 2. Maybe we do deploy smart contracts and we've got some DeFi stuff. You're swapping tokens around. You want to move your Doge back to the layer 1. You should be able to do that fully trustlessly and, again, not have to work with a multi-sig or hand your hard-earned Doge coins over to someone else. It's quite difficult because we can't use the techniques that we use to verify ZKPs on something like a Bitcoin or other UTXO-based networks because Doge has all these limitations. For instance, a script can only be 520 bytes, and the block is only 1 megabyte. So we can't do the opcat tricks that we do on Bitcoin for Doge without making fundamental changes to the protocol. But again, this is very difficult to push through. So we introduced an opcode called op check groth16 verify. And basically what it does is it verifies a very succinct zero-knowledge proof called groth16. And it happens to just fit in a Dogecoin script. And what this allows us to do is to prove 1 million transactions and have the on-chain footprint, the amount of data that we're using on-chain, only be 520 bytes. So we have this kind of best of both worlds situation where if we enable this, not only are we not going to be flooding the Dogecoin blockchain, not allowing people to transact, but actually we'll be making the Dogecoin vastly more scalable than it is today. And this just kind of goes into the specifics, how we made it work. It turns out you have to provide some of the verifier key in the unlock script, but it works. It's fully trustless, and we've already implemented a fork of Dogecoin that has it. In addition to implementing the opcode, though, we also implemented a full zkRollup that uses the opcode, and it's called QeD Rollup. QeD Rollup has all of the basic features that we want in a trustless L2. You can deposit your money in, you can claim those deposits, you can transact on L2, we can do 1 million transactions, and again, the footprint on Doge, only 520 bytes. And then at the end of the day, if you want to move your funds from, your L2s back to Doge, you can do it trustlessly with our withdraw function. So the way that this works is using a thing called sighash. So on Bitcoin, when you sign a transaction, you have to sign this hash, which contains, you can think of it as a description of what money you're spending, so maybe some previous transfer that you had, or your existing balance, and who are you. And we also need to say, okay, where are we going to be sending the money to? right? Because we want to make sure that the thing we're signing has all that information inside so that when we send that transaction off to the blockchain knows that I actually approve to spend this amount of money to send money to this person. Now, if we provide that SIG hash, which contains all that information, to the zero-knowledge proof, that zero-knowledge proof knows what tokens were sent to the block, as well as what tokens are being withdrawn from the block. So using this, we can force, using a zero-knowledge proof, that any deposits that are made are included in a deposits tree on the layer 2, so the users can claim them, as well as enforcing that any of the withdrawals made by the users on the layer 2 are reflected in the transaction that occurs on layer 1. So this is, I won't get too much into this, but this is sort of how our state model works. In each block, we're proving that the L2 transitions from some start state root of this big Merkle tree to a new state root. And in addition, we're proving that this change in the state of the chain is accurately reflected by the inputs and outputs of the SIG hash of the transaction that we're making. So we're proving that any of the deposits that were made to the rollup are accurately added to the deposits tree so the users can claim them. And any withdrawals that are made by the transaction were authorized by the users on the layer 2, and their balances were appropriately deducted from. So no double spending. Yeah, this is just going into different trees. We have limited time, so I won't go into that. But yeah, like, people have proposed ZKP opcodes on Bitcoin before. In addition to actually implementing the opcode and making a working version of Dogecoin that has this, we also thought that it would make sense when we build community consensus around the opcode to actually build a full rollup that does all of the things that we want, to prove to the world that not only if you add this opcode will you be able to verify ZKPs on Dogecoin, but you'll also be able to trustlessly scale Dogecoin and provide a great value to the users of Dogecoin. So here we go. Here is QeD Rollup. Yeah, so you can see over here, I'm depositing into QeD Rollup. Each block has a different deposit address. And now what I'm going to do is I'm going to claim that deposit by pasting the transaction ID in there. And then what we're going to do is we're going to sign this deposit claim hash with the same public key that we use to deposit in. And then we can do some on-chain transfers, as many as we like. It's not going to change the proof size. And once we're done with that, if we want to withdraw back, we just send a withdrawal action, sign it with our nice web wallet, and yeah, we can see that the block has now been proved. And if we look over here, it'll get to it. That address that I withdrew to, if I refresh the balance, it has in fact been funded. So yeah, like ZKPs on Dogecoin are also rather special as far as it goes, or as far as like layer 2s go. Because on Ethereum, all of the layer 2s are essentially competing with Ethereum for the same dApps. Like any dApp you can build on an Arbitrum, you could also build on the Ethereum layer 1. It's just more expensive for gas. But with Doge, it's very different, because we can't build DeFi on Doge, right? We don't have smart contracts on Doge. We don't have scalability. We have small block sizes that make it a very secure network. But at the same time, all of this functionality is missing. And now with check Groth 16 verify and our open source QeD Rollup, which by the way is already on GitHub if anyone wants to fork it and make some cool rollups, you can build these things on one of crypto's favorite, or most enthusiastic communities, let's say. So I can imagine, like, if you want to launch a meme coin, what better place to launch it than on Dogecoin? If you want to make a meme coin DEX or a pump.fun kind of a project, why not launch it on Dogecoin? It makes sense. And yeah, with this opcode, we'll be able to do that. So in addition to making this like rollup, we wanted to prove that we could really scale Dogecoin with this. So in addition to just implementing the basics, we also made a distributed prover that can prove blocks in O of log n time. So the witness generation for the blocks is still serial, but the vast majority of your block generation time is spent proving. And the way that this works is we split up all the transactions into individual proofs, and then we recursively verify those in a proof tree that culminates in that state transition proof there. Once we've got that, we generate individual proofs for each input to the block transaction, and then we generate our Groth 16 proof, which is eventually verified on chain. So to give you guys some context, a block with, let's say, I don't know, 10 transactions takes, around 25 seconds. And a block with 100,000 transactions takes around 50 seconds. So you can really scale up the amount of transactions that you're running without increasing the block time. And as we all know, block time is very important for user experience because the longer the block time is, the longer you have to wait for your transaction to be confirmed. So I'm sorry, 19 seconds. It's faster than that. But yeah, math, right? Proof of math. But yeah, so this is the architecture over here. This is a proof of concept. This is not our flagship blockchain. This is more just a way for us to give something to the Dogecoin community so people know what's possible. Yeah, like we built it around Redis. Would there be a better message queue that we could use? Sure, but proof of concept. And it doesn't have decentralized data availability right now. You can add it. It's not too trivial or it's not too difficult to add. And also, like the proof workers aren't working on a P2P network, although they are distributed. It uses like centralized message queues for the message passing and job scheduling. But yeah, and there's no smart contracts. But we will soon have a solution to this all, and it's called QeD. So QeD gives you full proof of math security. No economic models that could be broken or optimistic rollups that could be DDoSed. Pure Validium proof of math. We have a global state like Ethereum. We support multiple zk VMs by allowing for client-side proving. And most importantly, we can scale real big because our state model is built for this kind of tree proving structure. And we have hard guarantees since we have hard guarantees against race conditions, we can build our blocks massively parallel and take advantage of some of the same scaling techniques that are used by Web 2. But yeah, so we support tons of different programming languages. Yeah, if you don't see your favorite language here, hopefully we can add support for it soon. But yeah, thanks for everyone listening. Go Dogecoin. If you're interested in building something on Dogecoin, definitely get in touch. Also, we're very aggressively hiring, so anyone who wants to work on a cool project and be a part of a great community, please just come up to me. I'll be walking around or hit me up on Twitter. But yeah, thanks so much, guys.